In Part 7 of Lecture 1, we will discuss redirection, pipes, and processes. When programs begin their execution, their processes have three data streams available to them. Standard input, which by default is the source of input. Standard output, which is by default the destination of output. And standard error, which exists to allow the programs a place to send error messages. Under normal circumstances, this standard input is your keyboard, and standard output is your screen. Standard error is also, by default, your screen. The whole idea of redirection is that you can replace any one of these, or all three, with a file. The great advantage is that you can now use a file for either input or output without needing for the program to be rewritten. This is enormously useful and is part of the Unix-Linux philosophy of creating small software tools and using them together to create larger ones. We already know that ls by itself will list the files that are in the current directory on the screen. But if I write ls greater than file list, it will place this list of file names in the file called file list. Similarly, if I type cat f1, f2, f3 is greater than temp, it will then write the contents of all three files in order in a file called temp. In both cases, if a file already exists with that name, it will overwrite the original file. The new file will contain only the contents of the three files in the cat command. If I want this output to appear at the end of the earlier file with a given name, I use greater than. That will place the standard output at the end of the pre-existing file. If the file doesn't exist, it will create a new file with the standard file redirected to it. Not every Linux system has a mail utility fully installed. That includes both Panther and CompSci. If we had this utility, we would first type mail, Mary, and then press the Enter key, and then afterwards type our message. But if the file message already exists, we can type mail Mary less than message. It will insert into the email the contents of the file named message. If I type who greater than temp, it will create a file named temp that contains the login names of users on the system. If I subsequently type sort less than temp, it will print these out in order. If I type who greater than temp, it will create a file named temp that contains the login names of users on the system. If I subsequently type wc space -l less than temp, it will give me the number of lines in the file. Since it writes one line per user, that number is the number of users on the system. If I type ls greater than temp, it will create a file named temp that contains the names of files in the current directory. If I type pr space -3 less than temp, it will give me those names in a 3-column format. If I type who greater than temp, it will create a file named temp that contains the login names of users on the system. If I subsequently type grep Mary less than temp, it will print out any line with Mary's name. Please keep in mind that if we have a user named Rosemary, it will print that as well. Typing sort less than temp and sort temp will do the same thing. Print the lines of the file temp in sorted order. If I type sort without entering a file name, it will allow me to type input, and it will allow this until I press Ctrl-C to kill the program, or Control D to indicate that's the end of the input. If I type Control D, it will then list the lines that I typed in sorted order, as you see on the slide. It is very clumsy to use temporary files in this fashion. That's why pipes exist. A pipe connects the execution of two programs. It takes the standard input of the first program and uses it as standard input for the second program. Each of these examples correspond to the examples that we saw just before. Who vertical line sort gets the login names of users on the system, sorts and displays them. Who vertical line WC space -L get the login names as before and displays the count of lines, one line per login name. ls vertical line WC space -L gets the names of the files in this directory and displays the number of lines, one file per line. ls vertical line PR space -3 will print the login names in 3 columns. Who vertical line grep Mary will print the logins that contain the name Mary. You can have more than one pipe per command line. When we type who vertical line grep Mary vertical line WC space -L, we will get the login names, forward only those lines with Mary's name, and display the number of lines containing it. What you are looking at is how data normally flows through programs. Standard input is read in by the programs, and eventually there will be output, usually going out through standard output. There is always the possibility of error messages. These will go out through standard error, so it can be redirected separately from standard output. There is a special name for an instance of running a program. It's called a process. There are other names for it as well. For example, a job or a task. Which name is used depends on the operating system, but the underlying concept is the same. In the example, the user typed date, semicolon, who. The semicolon allows you to specify 2 separate program runs. These 2 processes will usually run in the specified order and are not usually dependent on each other. This is different from a pipe. Nothing in the commands makes it clear that they will share data. Most of what we do when running Linux is in the foreground. In other words, we are interacting directly with this program run, but I don't necessarily need to do so. If we add an ampersand to the end of a command line, it will run in the background. There will be a process identification number shown, and it will then allow us to go ahead and do whatever else we wish to do on the computer. In the example on the screen, we see that the user is able to print the redirected output from the background process. It is important to keep in mind that the ampersand applies to all the processes in the pipe. Wait is a built-in command of Linux that waits for the completion of any running processes. If we are running several processes through a series of pipes, it will wait for the last one. This is not much of an issue in this example, because it completes the program execution very quickly. Please note that kill space -9 space 6944 will terminate process number 6944. We will talk more about kill later in the course. PS is an abbreviation for process status. It will list the processes run by the current user. PS space -A lists all the processes that belong to a given terminal. PS space -G is currently deprecated.